Good morning, guys. My name is Terry Fan. To my right, Ian Forsyth, Kevin Lee, Greg Turner, Luke Fan, Fu Nguyen, and Juan Delgado. We're team enforcers. In recent years, we've seen a rise of public distrust in law enforcement, which in turn makes the job more challenging for police officers. To become more transparent, law enforcement employ the use of body cam. The body cam works well, but it has limitations. First of all, the body cam is currently mounted on the officer's chest, so it has limited field of view, and it doesn't allow us to see what the officer actually sees. Second of all, the body cam requires manual switching before engagement, and in its current design, it can be mounted incorrectly without proper support. So working with STG, a team and I would design a helmet awareness system that is more efficient and most importantly, does not interfere with officers' plan operation. We call this the Enforcer. The Enforcer has a built-in camera that can live stream at 177 degrees field of view and will transition to record in high definition when an event is triggered or when the officer's siren is triggered. It also has built-in sensors that will automatically turn on when the Enforcer is mounted and will turn off when it's not. The sensor will also detect violent impact and will send impact data to dispatch automatically via the phone applications. And to see how all these features come together, my team will take it away.
So like every product, and Terry just touched on this a little bit, but we all want to know what the helmet actually does and what the features are. So to the right of the PowerPoint, you can see a list of general features that we have, such as LED lights for increased visibility, Bluetooth network that will be connected to the officer's device of an iPad and the phone that the officer obtained. And then our most important component that we have is the video camera. This will be recording in black and white, color, and video, and audio. Then, as Terry mentioned, you're going to have the force detection that calls help to dispatch that we'll dig in a little later. And then the hands-on, or hands-free, I should say, power on and off feature with a long battery life that will last 8 to 10 hours, which is about one officer's shift. So putting all this into a theoretical perspective, we have a flow chart that we designed that explains how the system works, starting with the Raspberry Pi turning on from low power mode, which is essentially off to save power. And that leads all the way up to stream black and white, and then then eventually to color when set by the accelerometer or the sirens. So going to the next slide, Kevin's going to go dig deeper into the components that we have in the system.
So here we have a general block diagram of our hardware components. So to the right we have our proximity sensor and our PCB, which comprises of a microcontroller and a power controller. These two parts or components actually make up our automatic on-off system. And towards the center we have a Raspberry Pi 3, which is our main central processing unit. This combines all our accelerometers, our sirens, our camera, as well as our phone application. Not only does the Raspberry Pi have the ability to connect to peripherals, but it also streams to a tablet provided by SDG. So to talk a bit more about the PCB part, we have Duke.
Alright, so during the design development, we decided to create a PCB. So one of the key features for the PCB is going to bring together all the components like the microcontroller, PIC16, the proximity sensor, the Raspberry Pi 3, and then the power booster board. So technically what the power booster board does is going to provide 3.3 and 5 volt to power various components on our system. And it can be also used to recharge the battery. And so when we design the PCB, we're shooting for lightweight and compact so it can be easy to integrate into the helmet itself. So as you see over here is two pictures for the top layer and the bottom layer of how our final PCB board is going to look like. And then to understand more about how our on-off system works, I'm going to pass back to Kevin.
Like how I mentioned earlier, our what's called on-off system comprises of two main components, which is our PIC microcontroller as well as our proximity sensor. These two components actually communicate to each other using a protocol known as I2C. The reason we chose this on-off system, or made it autonomous, is that in order to improve power consumption as well as lower our footprint without needing a physical switch, we use these two components to do such a task. So if we play the video, we have actually a demonstration of Ian actually putting on the helmet. So embedded on the side of the helmet, we actually have an LED indicator that will shine up as the person puts on the helmet, indicating that the entire system is on. Similarly, if Ian were to take this off, this LED indicator will shut down the Pi within a few seconds. So let's talk a bit more about the streaming and camera aspects. We have Juan.
So during the development process, we tested various cameras. As you can see on the left-hand side, this is just a regular stock camera, and the one on the right is a fisheye lens. Now, what the fisheye lens camera does, it allows us to capture more of what the officer is seeing because it has a greater field of view. That fisheye lens that we chose has a field of vision of 177 degrees, so we went with that. So for the streaming aspect of our project, we decided to use the camera module on board the Raspberry Pi. Now, the reason why we did that was to be able to use an API known as Pi Camera. Now, what Pi Camera does, it enables us to stream black and white and change the color easily. As far as the video player, we tested many video players, and we decided to go with MX Player. And now the reason why we did that was because we're able to stream the video in real time using a protocol known as RTSP, Real-Time Streaming Protocol. Now, you could download MX Player in any Android device, and anybody could see the stream if they have the IP address of the Raspberry Pi and you're on the same network. So the system is continuously streaming in black and white. Now, the reason why it does this is to save on memory and battery life. This is just a short clip of what I'm actually seeing on that Asus notepad. Aside from streaming in black and white, the video changes to color when various events are triggered. I'm going to let Duke talk more about these events.
All right, so as Juan previously mentioned, there are going to be two events that will trigger the system to change the initial state from black and white to color. So the first one is the accelerometer will be mounted on the side of the helmet. So technically, it will detect any force or impact that will happen to the officers. And the second one is the silence module, which we also call it the base unit. So this is the indication whenever the officer is in pursuit mode, so that the emergency light pop up. So here's a video of demonstration of how our system is going to work. So initially, the system is going to start streaming in black and white, and then somebody come close to the helmet and hit it within a certain force, it's going to trigger the event to start streaming in color. And also the same thing happened with the siren module. And so as long as the emergency light is light up, so that the system will start streaming in color. Can you pause the video? Yeah. And then we also add a little text for annotation on top corner of the right-hand side to differentiate between the color mode for the accelerometer and the siren module. And also next. So for demonstration purposes, we were able to create an event log by using a simple HTTP servers. So technically what it does is, it's going to have an indication whenever the system is starting, the siren trigger or the accelerometer trigger. And also we're going to have a real date and time updated. And also we was able to develop a circular buffer algorithm that will record 5 seconds before the event's being triggered, so that we have a video footage of what happens to the officer. And all the video will be stored and compressed in the MP4 format, and which can be viewable later by connecting to the servers. And next, we want to send all the data to the Android dispatch phone, which will require an Android application. And then I will let Greg handle about it.
All right, so this is the Enforcer app. And this app will be used in the event of emergency. So when our officer has been involved in an accident or has received considerable impact, the accelerometer within the helmet will have exceeded a certain threshold. This will trigger a Bluetooth signal to be sent from the Raspberry Pi to the Enforcer app on the officer's registered Android device. From there, the Enforcer app will gather the necessary data, take a screenshot like you see above, and send this information off to the dispatcher in order for the dispatcher to provide immediate assistance for the fallen officer. This information that's included in the screenshot will consist of the officer's name, photo, badge number, and helmet number, along with the information about the event itself. This event information will consist of GPS location in the form of the nearest physical address, a timestamp of when the event occurred, and the amount of force that the officer received. We will also be including a map. Since we are using Google API, there's a chance that we might not receive the nearest physical address. So what we did is, by having this map, we'll be able to pinpoint exactly where the officer is at. Along with all this information, we wanted to provide information about the unit within the helmet. So we wanted to let the officer know when the unit is on or off, when it is connected via Bluetooth, and the amount of battery life that the unit has during its use. So now we'll go ahead and pass it on to Ian to let to see how everything is integrated together.
So when doing the integration testing, like every other project here, we ran challenges when coming to the integration process. So there's three main topics that we came across: was stability, weight distribution, and lighting in terms of the proximity sensor. Starting with stability, we didn't want any of the components moving around or possibly being damaged when the officer is putting the helmet in use. So in order to remedy that, we ended up using Velcro straps, despite our first attempt with zip ties, because we found it more snug and secure, and along with the foam cutouts and a wire harness, just to make everything stable and just ensure that there's no damage to the components. Following that, we come to the weight distribution, where we didn't want too much weight on one side of the helmet for the officer to feel. We want him to put on the helmet and feel a perfect balance. So as you can see from the picture on the presentation, we distributed the components evenly among the helmet. Lastly, we come to the lighting challenge, where we didn't want the helmet to turn on. Say if you put the helmet down on the floor after the officer's done using the helmet, we wouldn't want that dark environment to simulate the officer putting on the helmet. So to fix that problem, that was easily done through software to make the proximity sensor that will detect the officer not as sensitive to the lighting. And so now, just to cap it off and see how the total cost is, we will take care of that.
So to build a helmet camera system, we request the amount of $445. The most of purchase take on computer system 54%. There are Raspberry Pi 3 memory card and fixed iClan. The second purchase is on PCB due to the power supply, power amplifier that take up 23%, and miscellaneous take 5%, and sensor take 15%, 17% of purchase. So we start the purchase balance is 1,000. We spend 445. We select over 555. Here is our milestone. So at this time, everything finished on time. We happy. We done with the streaming video. We got the BCB. We have the phone application done and finished the integration and testing. Finally, we have the final product which fully functional. The helmet camera system delivered to STG. So we're ready for deciding tomorrow. Now I will pass to Terry and loosen our project.
So for the last 3 months, the team and I have been researching, prototyping, and consulting with STG and CHP officer to create the product you see today. Currently, the Porsche is only designed for CHP officers. In future revision, we hope that it will be adopted by all law enforcement as a way to increase transparency for both law enforcement and citizens. Thank you.